Ptolemy fudged his model further by moving the Earth away from the center of the deferent and having the deferent rotate around an arbitrary point in space, the equant. But now the works of astronomers like al-Battani started to strain Ptolemy's ideas to breaking point. Their careful observations began to suggest that even with Ptolemy's unwieldy equants and deferents, the actual behavior of the heavens didn't fit the data.
So what do you do if you were an astronomer living in Baghdad and you have all those results on your table? The very first requirement is to say, this Greek tradition is not as trustworthy as it is advertised to be. And now, of course, they begin to say, if the fundamental values of the astronomical tradition of the Greeks, which we could double check and we found them to be in error, what else is in error? They began to question now the more basic foundational astronomical, cosmological foundations of the Greek tradition.
And question they did. What's absolutely striking about the writings of Islamic scholars by the 9th century is the increasing use of the word shukuk, which in English means doubts. They show that it's sometimes necessary to doubt an idea that everyone around you believes unquestioningly. Islamic doubting of Greek astronomy began the slow process of undermining the notion that the Earth is at the center of the universe. To doubt takes great courage and imagination. But if the great dialogue between Islamic and European astronomers shows anything, it's that doubt, or shukuk, is the engine that drives science forward. One of the first great shukuk scientists was called Ibn al-Haytham. He was born in the Iraqi city of Basra in 965 AD and was among the first to argue passionately that scientific ideas are only valid if they're mathematically consistent and reflect reality. And when he applied his fierce, rigorous intelligence to Greek astronomy, he immediately spotted that there was a fundamental contradiction at its heart. On the one hand, Greek cosmology argued that everything in the heavens revolves around the Earth. On the other hand, Ptolemy, in his Almagest, argued that if you want to mathematically predict how the sun and planets move, you have to pretend that they go around an arbitrary point in space, the so-called equant. This is clearly a contradiction. The heavens can't both go around the Earth and not go around it at the same time. Ibn al-Haytham hated this nonsensical contradiction. In the early 11th century, he wrote a paper, Al-Shukuk ala Ptolemaios, or Doubts on Ptolemy. In it, he writes with barely contained frustration, Ptolemy assumes an arrangement that cannot exist.
Ibn al-Haytham says that is a total absurdity. We cannot accept that, and furthermore, he says, it's not a slip of a tongue. Ptolemy knew that it was an absurdity, and he shows us where Ptolemy himself was embarrassed by having to introduce it. So he says there is a fundamental reasoning problem, meaning that the Greeks knew, that Ptolemy knew that he was making a mistake, but he knew he couldn't do any better, and hence now the challenge is to do one notch better, and hence to be able to fix this. That, in my explanation, begins to be the program of research for all astronomers to come.
In order to achieve that project, you had to be convinced that it was possible to make high-precision mathematical models of the way in which planets and stars move that would really capture how they are in the heavens.
Ibn al-Haytham, in effect, laid down the challenge for all astronomers who followed, which was to come up with an explanation for how the heavens move that is both mathematically consistent and agrees with what we observe. The final answer to this would come from faraway Europe with Copernicus and others. But the next and crucial breakthrough came somewhat closer. The top of this mountain in northern Iran was the adopted home of the man who was the next of Copernicus's Islamic influences, Nasruddin al-Tusi. He would succeed in rewriting Ptolemy's theory, which would ultimately lead to the overthrow of the geocentric view of the universe, and so the birth of the modern scientific age. This is the remote castle of Alamut, al-Tusi's adopted home. For many years, it was the home of a Muslim sect called the Ismailis. It's a lovely secluded spot, and it was the center of the Ismaili movement. It's not surprising that al-Tusi would find a home here. And it wasn't just him. Many other scholars were gathered here, and there seems to have been a library. It was a center for learning as well as a military stronghold.
Here, this is the main gate, northern gate of the upper castle of Hassan Sabah.
A new archaeological dig is now revealing under the castle, hewn into the living rock, a warren of rooms and studies, a mosque and living quarters for this extraordinary community of soldiers and scientists.
This is the court of mosque or center of headquarter of castle.
And it was within these cramped conditions that al-Tusi started his masterwork of the shukuk, or the doubts, the tadhkirah. In it, he finds an answer to Ibn al-Haytham's first challenge: how to eliminate Ptolemy's equant. Instead of a sphere rotating around an arbitrary point in space, al-Tusi devised a series of two nested circles, which rotate around each other in such a way that they eliminate the equant. The nested circles became known as a Tusi couple. This is the mathematical system that finds its way into Copernicus's work some 300 years later. Having found a solution to the equant problem, al-Tusi now wanted to complete the task Ibn al-Haytham had started 200 years earlier, to find a consistent mathematical description of the movement of the celestial bodies. But to do that, he needed better data, which meant bigger and better equipment than he was ever going to find here at Alamut. And then something happened which changed al-Tusi's life forever. The Mongols. Streaming in from the east, an army of Mongols led by Haluga Khan marched into Iran, crushing everything before them. By 1255, they had reached the foothills of Alamut, intent on its destruction. Then, in a brilliant piece of diplomacy, al-Tusi managed to both save his own skin and satisfy his scientific ambition. He visited the Mongol leader and played on his deep astrological superstition. Convincing him he could tell the future if only he had new equipment, al-Tusi persuaded the Khan to make him his head scientist and to build him just a few hundred miles away, perched on a hilltop where the air was clear, the largest observatory the world had ever seen.